for students?
It would it'd be numbered tickets.
Okay.
So, but I'll click on it because that is one of the ones you're more traditionally would see. One that's not opening. Well, there we go. Preview. What number was that again? Sorry.
13.
Okay. All right,
I
there
have
it is.
everything else except for the ones right under revenue.
Oh, okay. So back here and grab that. Then get back over here. In this table is what you're wanting to find, right?
Yes.
Okay. I'm going to need everything up here. All right, so get back to there. I'm going to take I like that. Okay. The admission at a Bengals baseball game was $7.50 for adults and $4.25 for students. The ticket office took in $579.75 for 102 people that paid, right? So that's the key. There was 192 people that paid, right? The cost per ticket for an adult was $7.50 and then $4.25. So you're basically taking these two right here and multiplying it. So that's how you get 7.5x and then 4.25y. And that's going to all equal $579.75. So it's going to give us two equations right here. So we have x plus y equals 192. And 7.5 times the number of adult tickets plus 4.25 times the kids' tickets would give me a total of $579.75. So there's two equations really. When I normally teach this face-to-face, I kind of said it. The table is more for what you would do for more of a linear type solving equation type thing instead of a system. So I kind of talk about the two equations that we have here. The x plus y equals 192. We call that a how many or total. I got 192 tickets total. What are they comprised of? They're comprised of adult and child. So x plus y equals 192. And then the second equation is kind of what we deem as a value type equation. So there's sometimes type of value or amount times x plus sometimes some type of value or amount times y equals some total amount of dollars or total amount of something. Okay, so that's kind of how they do that to set those up. Now, I only showed you how to do it by graphing, right? That's really the only two ways I showed you, or really the only way, period, I showed you. Is that correct? You can do this on the calculator other ways, reduce row echelon form or anything like that, but I guess for simplistic purposes to carry on what we've been doing, you would just take this and then you would move the x over. So that's let me grab a different y equals negative x plus 192. That'd go in y1. And then this one would be what? Y equals negative 7.5 over 4.25x plus 579.75 over 4.25. So there's both of them in slope-intercept form, and you can find where they intersect, and they'll give you an X and a Y, and the X will go for adult, and the Y will go for a child's ticket, right? So that's kind of, and I tend to put those in parentheses, these fractions, when I'm doing it. So did that help a little bit?
Yes.
Okay. Okay, let's see who else is here. Can you repeat the first part again? My speaker went crazy. Kennedy is having some speaker issues. Yeah, here's the cost for the adult. Here's the cost for the student, 750 and 425. If you multiply the X times this, it gives you the revenue, right? The cost per ticket times number of tickets is revenue. So you do that for both of them, and then you've got a total revenue down here, and then the other equation is X plus Y equals 192. So that gives you a summation type equation. So, all right.
Okay, thank you.
Yep. Okay, that was 8.1. Where do we go now? Where do you want to go now? Yeah. Any more in 8.1? Just curious, did anybody solve them by elimination or substitution? Or did you just graph them? Or, hate to ask you this, but have you solved them?
I solved it, and I solved it a way that I was taught in high school. I don't really remember the name for it.
You probably done elimination or substitution.
Yeah, I changed it, and yeah, I did elimination, I think.
Yeah, where you're trying to get the coefficients to be the same number, but maybe opposite signs, so they eliminate.
Yes.
Yeah. You can do that. The problems that they've started out with are doing graphing, solving by graphing. Now, I can show you. Well, it's better just to do graphing, because that way you've got all three. You can see all three. But you can do it by elimination as well. Just remember the rules. If your variables drop, you've got two numbers being compared. If the left side equals right side, then that's infinite amount of solutions. But if the left side doesn't equal right side, meaning like 1 doesn't equal 2, that'd be a no solution, which would mean it's a parallel line. So just kind of be aware of that. Okay, where do you want to go? Have y'all got into the regressions? That's 2.6, I think.
No, sir, not yet.
Okay, that's strictly all by calculator. So if you don't have a TI 8384, you are up the creek without a paddle. Okay. So
I started on that today, but
go ahead. Sorry.
It's okay. Said if we didn't have a TI TX calculator, we were what?
You're gonna be hurting, unless I don't know what.
Okay.
Yeah, you got to do one. You've got to have a TI that, or a calculator that will do a linear regression.
Okay.
Yeah. You're gonna be hard pressed to be able to do section 1.6 if you don't. You're gonna be lost. So that's something you don't want to be, because that's not the only regression you're going to be doing. You'll be doing linear, quadratic, exponential. So there's about 3 or 4 exponential. Not three or four regressional analysis within these chapters that you'll have to do as we progress through the semester. So you need to get one. All right, where you want to go? All right, section 1.4, number 11, fill in the missing table. So, all right, so here's what we'll do. You got to treat each one of them as an independent slope, right? Let's go here. Cut. Well, that's don't want to give me a new one there, but there, we'll just do it this way. All right, so I'm going to look at changing X over here and changing Y over there. The first, you got to have 2 points in order to find slope, right? So go away. Go away there. I've got a missing point here. So there's really nothing I can do on these, first two. The only thing I'm going to be able to do is look at these last two sets, because see, I have a missing one here. And then again, a missing bit of information with another value. So from 6 to 10 is an increase of 4. So that's a positive 4 change. And then from 7 to -5 is a decrease of 12. Now, what we want to consider is this. Slope is changing Y. Over changing X. Okay. So we're looking at -12 over 4. All right. That's my slope. But that's my slope not simplified. So I need to simplify that. And when I simplify that, what it does is it gives me back a unit rate. Okay. So -12 over 4 is really -3 over 1, which that means, why the heck does it keep doing that? All right. For every 1 movement in the X, I'm going down by 3 in the Y. So I'm getting it back to a unit rate, okay? Where the X is moving by 1, what is my Y doing? So for here, I'm moving 2 spots, right? In the X's, I'm moving up 2, right? You agree? So if I'm moving 2, then I'm really going 2 -3s, which would be a -6, right? So if each move represents a -3 change in my Y, then I'm moving 2 on the X, which 2 times -3 is -6. So I'm changing -6. So 34, that'd be 28. Okay. Now from 28 down to 16 is a change of -12, right? Y'all agree? 28 to 18 is 10. Yeah. Okay, so I've already got a change in 12 here, and I know it's 4, right? So if I go from -1 and I go up 4 on the number line, I will be at 3.
3?
Right?
Yes, sir.
Okay, so I'm going to show you another way on how to do this, and it's setting up a nice little proportion. Okay. Okay, so -3 over 1. Now I'm going to set up its slope. Then it would be -12 over change in X. So we'll cross multiply. So divide both sides by -3. My change in X, man, boom. Change in X better be -12 over 3 is 4. And that's what I got right there. So you can use your slopes to find missing bits. A known slope that has a change in y over change in x to one that's missing a component. Okay. So yeah, that's how you can do that. All right.
Thank you.
All right. On number 18 on 1.4, if you're trying to put meters in here, it's saying units, right?
I just put the M for meters and it took it.
Ah, okay. Yeah, they're just wanting it, not the word, just a unit. So M. Yeah.
Yeah,
I tried that and it didn't work for me.
It didn't work for me either.
You got to put a space.
I did.
Number space M.
Yes.
Then you've got
Yes,
something
sir.
wrong. You got something wrong with your. Did you take this answer and divide it by 2?
No.
That's your problem. On the video that I put up for this section, I went back in. There's a call out thing that says take answer divide by 2, because what you're doing is your distance is taken into account of going from the surface down to the ocean floor and back. That's what the echo sounding does, right? It's setting up on top of the surface of the water, so it's going down, bouncing. So that distance is down and back. So if you want to know how deep it is, you take half of it. So that's your problem right there.
Okay.
Yeah. So take half of it and divide it by, put your number and then space M, and you should be okay.
Okay. Will that always be for every problem or just certain ones?
For this problem,
Okay.
yeah, this is the only one that's dealing with echo sounding. Or basically sonar is really what it is. So. Okay. All right. So what's your question? I don't know who asked that for this one, but what's your question on this particular section 1.6, number 6? Man, he wanted to take that. Cut. All right.
Sorry, that was me. That's Kennedy. I couldn't get what is the correlation coefficient of the regression line.
Okay. Do you have your correlation coefficients turned on?
On my calculator?
Yeah.
I'm not sure how to do that.
All right.
I'll figure it out.
No, I'll show you real quick. That's no problem. But I just want to make sure when it says let t sub 0 equals 1990, are y'all doing this?
Yes.
There's 6, there's 7, there's 8, there's 9, there's 10, right? It basically takes, instead of looking out in the X at 1900 and something, it slams it up against resetting the clock, puts it over against the Y-axis. So make sure that is something that you're doing. All right, so let's okay. Let's go to. I know there's a way to do this quicker, but let's just do this. And then we want to go to D, which is enter. No, sorry. Second, calculate, right? And you got to scroll down till you get to D, diagnostic on and off. So I went second 0, which is catalog. Turn this thing, okay. So you want diagnostic on, hit enter. Oh, cuss, I bet you. Yeah, I had an absolute value in that. I don't want that, so that burn it. Now I got to go all the way back through. I know there's a way to do. Oh, yeah, I do. Okay, let me show you this just in case you don't have what I'm about to show you again here in a second. All right, so second 0 turns to catalog, and you've got to go to diagnostic. So you want to go up to diagnostic on, hit enter, and when you do that, it'll give you R and R squared. You really want R, okay? But if you have an 84, you may even do it on an 83 too. Second mode, if you go down, let's see, yeah, see it says stat diagnostic on or off. For an 84, you can do it right there. I'm not sure if that'll do it for an 83. Okay, so there's two ways right there to make sure that that's done. Okay, second mode gets into your stuff.
Okay.
Yeah, and you're looking at R, not R squared. And the correlation, what that tells you is how close, because you're doing a linear, how close is it coming to being a really, really good correlation? Like it'll be +1 or -1. Those are your kind of limits if you think about it. +1 for a positive slope, -1 for a negative slope. And the closer you get to 1, positive or negative, the better and the more predictable that you can say that it's statistically significant, right?
Yes, sir.
There you go. All
Thank
right.
you.
You're welcome. Okay. What's your question?
Would the points on the line be MX? I mean MME? Or like, because it has estimate the slope and vertical intercepts of the line.
Yeah. So I'll show you.
How would you put the slope formula together? Would you do it by the graph?
Yeah, that's the only thing you can do it. I mean, unless you pull the points off of it, right? So look at
so that's rise over run?
Yeah, that's slope, right?
Yes, sir.
So what you want to do is you want to find a perfect grid mark where it's crossing at, and you have that, right? It's crossing perfectly right there.
0, 0?
No, well, the B would be 0, right?
Yes, sir.
Okay. Now you've got to find another point that crosses at a grid. It doesn't cross here. Let's see. So let's go here. It doesn't cross there. It doesn't cross perfectly there. Neither there, but it does right there. Okay. So, so from there, you just kind of look at it. You're looking for slope. Now, X is not slope. X is a variable, okay? So that's a common thing that people do. So we want to fix that. All right, so we're going up and over, right? So we're going up. The change in Y is 0.25, and the change in X is 1. So the slope would be 0.25 over 1, which is just a quarter, right?
Yes, sir.
So the slope is that. And instead, write an equation. So you have Y equals mx plus b. Now the b is 0, so if I put plus 0, it's not going to affect anything, so it'd just be y equals 1/4 x.
Okay, thank you.
You're welcome.